Okay, so you're going to talk me through, are you, just ways in which the rods can be used to arrive at some, being systematic, having some systemisation?
Yes, this is an activity that Goutard describes that she used with children
Right.
in her demonstration lessons to arrive at an understanding of subtraction and the structures behind that. So you have to close your eyes and look away a moment.
Okay.
Okay. I usually hide this up my sleeve. I haven't got long enough sleeves today. I'll hide it under here. Okay, under that paper I've got a rod. And if you did that with a class of year ones, they will all tell you they know what that rod is. You're all convinced they know. I'm not going to tell you what that is. I'm going to give you a clue about it. If you think you know, don't tell me. Okay? So the clue is that it's the gap between those. So you might have an idea in your head of what the rod might be that fills that gap. So the rod underneath here is the difference between those two rods. If you've got an idea of what you think it is, can you show me a pair of rods with the same difference? So that if I took my rod out from here, it would fit into the gap that you've created.
Mm-hmm. No.
This phase, you're working empirically.
Mm.
You're experimenting, you're gaining sensory data.
Mm.
Okay, so I'll take this out and I'll just check that you're right. So that's the rod that fits in there, and that's the rod that fits in there. Children's first reaction often is to take those same two rods to find out which rod fits into it and then find another pair. But you were trying to do it by eye, which is probably more difficult. The children would do something slightly more slightly easier. Are there any other pairs that would have the same difference? In a class of children, I'd probably go round saying, yep, well done, yep, well done. Any others? Now you've begun to work systematically. Can you see what it is in the arrangement you're making that makes that systematic rather than empirical? That you're reducing the size of the longest rod and you're compensating with the size of the other rod to maintain the same difference. So you're beginning to be systematic. Do you think you've got them all? Is that it?
No, I'm not sure I've got them all because I feel I can reduce this one by more, so therefore I can reduce that.
Would you be able to get them all?
I could get them all within the scope of these rods, but no, I guess I can start doing things like that, I guess, and then find something that would, so I can go a little bit beyond the scope of the rods.
One of the children said to me yesterday when I was teaching this lesson, if you got all the rods in this classroom, all the oranges and all the other rods, and you lined them all up, then you got all the rods out of someone else's classroom and lined them all up, and just took a green away, that would be the biggest one you could make. But obviously they're beginning to reach towards the idea that this is an infinite set. So that's still at a systematic level. Okay, so that's my original pair that I showed you. And if you could just take that pair, is there any way that if we just make sure that your pair and my pair do have the same difference, what would you have to do to map your pair of rods onto mine? What would you have to do to transform yours?
I'd have to shorten both of my rods by the same amount.
And what about if your pair of rods had been that pair? What would you have had to do to your pair there?
So now I'd have to lengthen both of the rods by the same amount.
Okay, so now you're working at a level of mastery. So you're able to transform any pair from that set into any other pair. And you're also beginning to perceive that any difference potentially contains any other member of that set with the same difference.
Now, what I'm getting a sense of here, and it links back to something you said earlier, that this is drawing on something that I do naturally.
Yes.
And what I'm doing, and I guess what other people are doing, but the sort of watching this and thinking about maths and thinking about teaching maths, is the idea that when you have a subtraction, that you can add the same number onto each of those numbers or subtract the same number. That sort of feels as if that's book knowledge. It feels as if that's sort of maths I have to learn, whereas I'm sensing what you're saying is that is really not what you have to learn. It's what I know already. It's a power. It's almost a natural power that I've got. And when it's stripped from particular numbers, then this is obvious to me. Yes. Are you finding that with children, that actually when they do this, these structures are obvious to children?
Yes. And this is, Goutard proposed this lesson, these ideas, and I've tried this again and again, and children always do the same thing. Yeah. So there must be something in mathematics and in children which leads them to the same conclusions. This is always what happens. Also, having tried to, as you say, introduce that book knowledge to children who are older, who haven't experienced this, they find it quite difficult. But if children have made that discovery for themselves, at that moment you had made that discovery of how to map that pair onto that pair. That was your discovery, it wasn't mine. And children have to feel that it's their discovery.